Hello, and welcome to another day of Advent of Code 2022 in Kotlin. It is day 10. Nice to see all of you here who have managed to either listen to the announcement yesterday evening or have otherwise just managed to follow the schedule and realize that the stream is not happening in the evening, but is kind of happening a little bit earlier today. The reason, of course, being the fact that we have a little bit of a winter party at JetBrains, and I don't want to miss that one. I briefly considered doing a stream from the Christmas party, but since it's at a venue that's not our offices, I wasn't sure how happy they were going to be with me filming there. I didn't want to put any people on stream who might not be comfortable being online, that kind of thing. So we're doing it a little bit earlier. We're doing it in the old and well-known comfortable setting of my studio and my home. And we're just going to do it the classic way. So yeah, as usual, if you are around, make sure you say hello in the chat. And also, let us know what you thought about day 10 and the puzzle that unlocked. This time not 12 hours ago. This morning at like 6 a.m., at least in my time zone. And in the meantime, while you're typing this out with stream delay, I can let you in on a secret. I did a little bit of a planning mistake. There's actually no tea in this cup yet. I'm just holding this to kind of pretend to have something to hold on to. This still needed to steep a little bit. So once again, the power of stalling has helped me get properly steeped tea. Just a little behind the scenes here for you. There's also some news which I thought might be disturbing to some people. As you remember, last night we were doing the live stream from the office, and I took the reading hat to the office. And of course, after now coming back from the office and it having been quite a late night, I mean, the odds of us having to use a replacement hat today would usually be pretty high. But as a Christmas miracle, I did manage to actually find the proper hat in the car. So don't worry. It's going to be fine. You can expect the same kind of reading quality as you've gotten used to over the last couple days. Don't worry. Just a little bit of a shock here. Don't worry. Yeah. Don't worry, it's all fine. That's the magic of Advent of Code. Everything turns out fine in the end. Okay, let's see here what people have to say. First of all, yes, hello early birds. Maya says it was a lovely puzzle, which is nice. It's not the emotion that I felt, but it's good that you did. I felt dumb that I over-engineered my solution. Well, that's sometimes the risk with Advent of Code, but that does not make it a worse solution. Remember, over-engineering is also something that's perfectly allowed in this context, right? I anticipated more of an int code computer to come. Okay, so you were maybe assuming... So this Olaf here is, of course, referencing one of the previous years where over the course of Advent of Code, you were kind of incrementally building more and more instructions for kind of a virtual machine emulator. With this one, of course, we kind of... It didn't go that far yet. Who knows what's going to happen tomorrow. But yeah, I mean, it's still very much a valid approach. It seemed easier, but cool, we've got some output variety this time. Yeah, we'll see about that in a moment as well. And I really like it when you have to read the result like that in part 2. We're also gonna, again, see this one. Okay. Wonderful. So my tea is now fortunately fully steeped, which means I can charge up and we can get ready to have some in-depth philosophical discussions about Advent of Code. Because just like all the previous days, of course, I am not alone today. With me today is Nicole Terk, who's an Android developer. Hi, Nicole.
Hi there, how's it going? Sorry for the funky noise. I am a bit sick. But
Oh, no worries. No worries. That's all good. I'm great. I'm very, very happy that I got up this morning and managed to do the task, and it was not like a 5-hour endeavor. So yeah, that
I
kind of
was
made me happy.
I was feeling the same, so I was really happy when it didn't took that long.
Yeah, I rewatched the talk by Eric Vastel, the creator of Advent of Code, actually earlier today, and he mentioned once again. He said, "Well, we take into account that people can probably spend more time on the puzzles during the weekend." And that's kind of just been echoing in my head. I'm like, oh no, oh boy. On the one time where I have to actually, have a presentable solution by like an earlier hour than usual. That's not gonna be good. But
Funny.
it all turned out fine.
Funny note, but I was reading exactly the same comment. Like, yeah, we take into consideration weekends, we take into consideration this and that. And I was like, crap, what did I enlist to? But no, it wasn't that bad.
Yeah, but in this case, I have to say, I said it pre-stream already. Kudos for committing to coming on here on day 10. That's a little bit more of a risk to take than coming on maybe day 3 or 4. I have to say.
Thank you. It was the data adjusted my skill a little bit better, so I was kind of ready for this.
So, are you someone who's been doing like Advent of Code or in general coding puzzles for longer, or is this kind of like a relatively new thing for you?
Funny thing, but I actually learned to code to do puzzles like this one. My background is biotechnology, nothing to be with coding and everything. But specifically Advent of Code, I learned about it a couple of years ago, but I have never finished it. So I have fun making these things. I don't know, my brain twisters.
Nice. Yeah. I think it's always fun, kind of getting out of the usual habits of of just creating, I don't know, some web applications or APIs or whatever, and going into a subject that's completely different.
Yeah, I agree. And it gives you a chance to, just use things that you don't normally use. Play around, try to figure something, print something cool on the screen. So yeah.
Yeah. I'm actually currently going through a book by James Buck. Let me just maybe pull that one up here real quick. Which is called Maze Algorithms, which is kind of a very fun, or mazes for programmers. I'm just gonna put a little ad up here, which is really fun because for me it tickles the same part of my brain that Advent of Code does, because it's working with something that I don't really have any connection to myself. Like, it's not something that I encounter in my day job or something that I'll ever be paid for. So it's really just like puzzling around on the computer and working with a type of structure that I've never seen before, just for the sake of it.
That's nice. I'm going to look it up. Thank you for the recommendation.
Yeah, so folks, if you need something to do after Advent of Code is over, this one might be an interesting little thing to go through. It's a book written actually in Ruby, or the code examples are written in Ruby, but Ruby is a very readable language. So when I work with it, I always do it in Kotlin, and it seems to work out just fine. All right, cool. So I think at this point we can already start and get into our reading session so that we can have plenty of time discussing the actual problem. All right, hat is on. It's fully charged since yesterday, even though it was in the car. It just kind of, it needs to rest. That's kind of how it works. But now it's fully charged. So we are today doing day 10, cathode ray tube. You avoid the robes, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritized getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. Unless, that is, you can design a replacement for the device's video system. It seems to be some kind of cathode ray tube screen and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. The CPU has a single register X, which starts with the value 1. It supports only 2 instructions. Add X V takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program, your puzzle input, to somehow tell the screen what to draw. Consider the following small program. No op, add x3, add x minus 5. Execution of this program proceeds as follows. At the start of the first cycle, the no op instruction begins execution. During the first cycle, x is 1. After the first cycle, the no op instruction finishes execution, doing nothing. At the start of the second cycle, the add x3 instruction begins execution. During the second cycle, x is still 1. During the third cycle, x is still 1. After the fourth cycle, the add x3 instruction finishes execution, setting x to 4. At the start of the fourth cycle, the add x minus 5 instruction begins execution, and during the fourth cycle, x is still 4. During the fifth cycle, x is still 4, but after the fifth cycle, the add x minus 5 instruction finishes execution, setting x to minus 1. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength, the cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. That is during the 20th, 60th, 100th, 140th, 180th, and 220th cycles. For example, consider this larger program, which does a bunch of things which I'm not going to read out. Because, yeah, it's a larger program. Just gonna keep on going. The interesting signal strengths can be determined as followed. During the 20th cycle, register X is the value 21, so the signal strength is 20 times 21 is 420. The 20th cycle occurs in the middle of the second add X minus 1, so the value of register X is the starting value, 1 plus all the other add X values up to that point. 1 plus 15 minus 11 plus 6. Minus 3 plus 5 minus 1 minus 8 plus 13 plus 4 is 21. During the 60th cycle, the register X has the value 19, so the signal strength is 60 times 19 is 1140, and then these continue for the other cycles. The sum of these signal strengths is 13,140. Find the signal strength during the 20th, 60th, 100th, 140th, 180th, and 220th cycles. What is the sum of these 6 signal strengths? Okay. Would you have preferred if I had read out the whole problem? Like the whole input?
I mean, it would have been nice to hear your voice over and over each of the steps, but it's okay. I understand.
Yeah. All right, so, Nicole, where did your mind kind of go when you saw this one?
Well, the initial idea was I saw this as a sequence. Like, X was going to be changing, and then whenever this add X appeared, it was going to be like a slot and then another. You can see it in my brain as a list where I'm just like skipping and updating X in the future values, right? So that's where my brain went to. Of course, when I started like thinking about it, I was like, I don't really need to plot the whole sequence. I just need the positions when I need the signal strength, right?
Mm-hmm.
So that's when this loop, I'm still going to, of course, do the loop through all these things. instead of like plotting the x value changes, I was just, of course, keeping the x value, but just adding the signal strength instead of adding the whole thing and then finding the positions, which was kind of my original naive idea. So that was kind of where my brain went to, and it was pretty straightforward, I think. I normally tend to like draw things when I'm stuck. Like I got a notebook and I start like drawing like, hey, how this behaves? But I didn't need to, because in my brain it was like pretty clear, just a list with the value changing, and just needed to grab some spots.
Okay. Well, then let's see what that looks like in your code. I'm just gonna open this one up here, and we're gonna get us started. First of all, as everyone can already see here, we have some benchmark annotations.
I was playing with benchmark, yes.
Nice. So
after this solution, I just start iterating small things, just to see what happened. Nothing major.
Okay.
Yeah.
Understood.
We can start with part 1.
Yeah. So part 1 with this one right here.
That one, yes. Part 1.
Okay. Great. So, let me make sure I zoom this one to the fullest extent so that people can read it easy. Okay.
Great. So here basically what I'm doing is some initialization of the state. Of course, I'm just setting x. I'm going to be keeping track of the current cycle where I am. And also, since in the first part we want the signal strength, I am just going to be keeping a value for that. After it, I just start iterating for each of the instructions. I notice that basically, regardless if I start with a no op or an add, I was going to have one cycle step. So I'm just like adding that first and validating. So which is just like adding the cycle, then checking if the current cycle is one of the ones I need to calculate. If so, I just add it. And then if the instruction is not a no op, because in my brain it was easier to do this instead of the add x, I'm just adding the extra cycle, which is basically whenever it's an add, I do the extra step jump and then just check again. And that's basically it.
I have to say I very much like the thought process of, oh yeah, I only have 2 instructions, so if it's not a no op, it's clearly an add x.
Exactly.
Which is fun.
It was just that. I just extracted a bit. I have a bit of repetitive code in there with the signals string and check. I was trying to like abstract it a bit, and that's where I enter in part 1b. If you may.
Okay. So I can follow you if you want to move your cursor somewhere. Okay, here it is. Okay.
Which basically is exactly the same. It's right here. It's exactly the same. The only part is that I create an internal function. I was also curious to see the performance between this because, you know, the whole anonymous class, yada, yada, yada thing. So I just basically created this one to abstract away the checks and adding it and just adding it in here, which is basically exactly the same, as you can see. The same kind of logic.
Okay. This is actually also, by the way, kind of a neat way of thinking about this one, about figuring out which cycles you're going for, right?
Yeah.
Which I have to. We can look at my solution a little bit later, but I kind of didn't come up with the idea that, of course, we could just go with the reminder being 20. I did some manual addition there because I was like, oh, I need to fit it within 40. So I gotta have mod 40 equals 0. That was kind of hardwired in my brain.
Yeah, I understand. I actually started like that. I was like, yeah, so it's 40, then the 20, and then it just struck to me like, hey, if I am adding 20, then I can just, put it there.
Yeah. This is something where I kind of got reminded a little bit also about university, because in university at some point they drilled modulo like arithmetic into our brain and like the operations that you're allowed to do with it. Like, if you have an equation where it's like equals 0, you're allowed to take out one part, move it over, just like in a regular equation. Yeah.
Yeah, no, in my case, I actually also reminded me of my times in the Maths Olympiads. I'm sorry, I'm a nerd. I was also playing with modular things and residues. So in my brain, it's just like automatically when I see model, it's like, okay, is the extra bit that is left after doing the division. So that's why my brain automatically jumped to, you know what, this is 20.
Nice.
So, yeah.
Well, I guess that automatically answers the question of, did your experience in Math Olympiads help you in Advent of Code? Today it clearly did.
Yeah. As I said, I learned to do this because I was actually looking for more problems like the Maths Olympiads, but that did the checking themselves, not me like going through it and not being sure if my solution was right. So I jump into this, and it was like a really organic jump, I'll say.
Okay.
So yeah, this was the second like solution that I'm pretty happy with. Like I didn't found a way to like move away from the duplication, so to say, of this check in here. But then I was like, before this stream, I was like thinking like, hey, what about my initial idea of creating the sequence? How would that compare? Because I was already playing with benchmark. So I was like, how would that compare with my other idea of like just iterating one? So that's how the part 1C, the sequence, was born. Which basically is, in this case, instead of like having the strength being just accumulating, I create the whole kind of X life per cycle. And then at the end, I just grab the specific parts that I want and I sum them up. And turn out it's not that efficient, by the way. It was like half the speed as the original one. Ish. So yeah, no. But it was fun to see, and that was what I was trying. And as you can see, the same idea is the same. I am just like doing this once, then I'm just adding this, but instead of like adding the string and validations, which was kind of my hope that the less validations could probably help a bit, but it didn't. It just make it a bit slower. So yeah, this was the other idea that came to me.
I have to say though, I like the approach of doing a sum off here and kind of inverting the relationship. So saying instead of going over your sequence and picking out the elements at specific indices, which I guess would have also been an option, like going this way around and taking the set. That's also pretty neat.
I mean, those were the only numbers I wanted, right?
Yeah, I mean this is nice because it's it shows a beautiful alternative to your mod 40 equals 20 approach, to just be like, to, as I have now come to call it, pull a Todd Ginsburg and just write out all the possible combinations that you need, and then that's gonna work just fine.
Yeah, it works. It probably looks a bit more hard-codey, but it works.
That's just you knowing like what's required. Yeah, exactly. Like you know the requirements. You don't need to scale infinitely. You just need to cover the things that are asked of you.
Exactly, and that's something that I actually really like about this kind of problems, is that they are really self-contained, so you can just play around, have fun, try different things, and now with benchmark you can just compare them up, like to see like, hey, how this compares with this other thing, how this thing moves if I do this or that. So that's quite fun in my opinion.
So from the benchmark perspective, you said there was no like very significant takeaways, but did you get any takeaways between the three parts that we've seen?
Yes, this sequence one was kind of half. It was less efficient, like it was half the number of operations. The other two were not that different. It was like the one with the function was a little bit better, but not for much.
Okay, so this is the function versus
duplicating the kind of same checks in there. I was expecting them to be same-ish because literally they're doing the same.
Yeah.
But no, it was a little bit faster.
Okay. Interesting.
Yeah.
As always, measurement over intuition, right? That's the part we get to learn over and over again.
Yeah, I was just fooling around basically.
Yeah. And again, that's more allowed in Advent of Code than anywhere else. So with that, we can move to part 2 of this problem, and then we can take a look at how you approach that one. So hat goes back on. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. In this system, there is no such thing as vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. You count the pixels on the CRT, 40 wide and 6 high. This CRT screen draws the top row of pixels left to right, then the row below that, and so on. The leftmost pixel in each row is in position 0, and the rightmost pixel in each row is in position 39. Like the CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle. Representing each pixel of the screen as a hashtag, here are the cycles during which the first and last pixel in each row are drawn. And we see our little illustration here. So by carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel, so a hashtag. Otherwise, the screen leaves the pixel dark, so a dot. The first few pixels from the larger example above are drawn as follows. We start with a sprite at the very left, and at the beginning we are executing at x15. The CRT draws the pixel in position 0, since that's where we are currently located. Because ADX takes 2 cycles, the CRT then draws another pixel before the sprite is moved by adding 15 to the register, meaning X is 16, and the sprite is moved. At that point, the next ADX execution starts with -11, but of course, the first thing that happens is that the CRT draws something. The sprite has been moved previously, so at this point, we're not getting a lit pixel anymore. And this continues onwards with the sprite being slightly moved once more, but of course the CRT drawing another pixel, again a dark one since they don't overlap. And this continues all the way until we arrive at a full line. Allowing the program to run to completion causes the CRT to produce the following image, which looks kind of like these interference patterns that you sometimes see. So first row is just 2s, then 3s, then blocks of 4s, 5, and so on. Render the image given by your program. What 8 capital letters appear on your CRT? And this is also the thing I think that, was it Maya beforehand said, or someone said that they really enjoy the type of problem where your output is some kind of 2D matrix and you just look using your eyes to find out the answer to the puzzle. It's kind of a cute approach.
Yeah, I really like this part as well, and I think it was Andreas, the one that said that.
Yes. Andreas, yeah. Sorry.
Yes. No.
Yeah.
Yeah, I just went to the comment, so it's fine. Yeah, it was kind of cute. I really liked this part. It was like, huh. When I arrived at the end and there was like no kind of example of expectation, it took me a minute to read it. I had to read it again. Like, what? Oh, interesting.
Yeah.
It was nice.
I have to admit, it gave me flashbacks a little bit because I used to do a CTF, like a capture the flag type contest, where one of the problems was also just like an advent of code type problem, which was essentially this, but 3-dimensional and with like way larger proportions, which is
Huh.
and like plotting a diagonal number in 3D space is kind of annoying. So I was like, okay, I have like a rough approach like of how I would do this one, and thank you, Eric, for not making this like a 3D sphere or like a 3D cube that I have to read this out of.
Yeah.
Yeah.
I was fearing it when I start seeing like they were reading pixels in the sprite and everything. I was like, oh no, this is the hard part. It's going to take forever. And then I saw the printout and I was like, okay, no, it's okay, it's okay. Because yeah, when I was playing around with the ACM kind of problems, there were also a lot where they have these weird plotting things where you have to ring off like spherical formulas and cones and everything in order to like plot things. So no, I was relieved it was just this.
That's pretty good to hear. Where like on a high level did your mind have to go anywhere, or did your mind go somewhere about this part is sponsored by another update again in the background? Did your mind go anywhere specifically? Where like I just need to change like 2 lines of code, or it's like I'll start re-engineering something like that?
Yeah, what I first had to do, of course, was to read again this because at the beginning I was not quite understanding how the drawing was going and like how this kind of pixel thing was changing. But once I reread like the couple of instruction examples, it was like, okay, I understand now. Before doing the jumping of finalizing the cycle and changing X, that's when it's kind of checking if X is in there or not.
Yeah.
So that was kind of the key for it. Besides that, my mind actually went and tried to do the sequence again, like tried to thought on this kind of weird array, but now in like this 6 rows array, and start seeing like X moving, and then this other thing, kind of 2 pointers, like X moving around, and the other pointing going slowly. And that was kind of how my brain visualized it. And
I see.
so yeah, after I just started writing it up again, it turned out I didn't have to change a lot, so it was nice.
Yeah, as you said, I think the time or the thing that gave me the most grief was kind of the order of when the drawing operation exactly happens. Like I had a couple of approaches where I either draw too early or too late, which then completely twists things. The crazy part was at some point I saw a solution in my output, which I was able to interpret as 8 characters of text, but they were not my solution, which is that part's kind of scary to me. Yeah. So okay, then let's see how you implemented this one.
Yes. So it's here in part 2. As you can see, it's pretty similar. Still have X, still have the current cycle. I just remove completely the strength thing that I was doing, and instead of that, the rest is the same. I am just printing the pixel value in there. And if we go up,
and you print the pixel value here. Okay.
Here. Something that I noticed that I didn't notice at the beginning, which after was like, of course, was that I had to adjust the thing for each of the rows. Because in my brain, X was going to move the same as the kind of pointer of time, but no, X never changed values higher than 40 or like 39 and less than 0, for example. So I had to adjust it, which again is just a model operation there. And that was it. This is just printing the thing, which is basically if it is in that range, it prints. If not, it prints the empty one. And that's it. I didn't have to change anything with that.
I think this is a very nice way of doing it. Actually, I think these parentheses might actually not be necessary.
Yes.
I think.
Yes, they're not.
Very good.
They
Look
were
at that.
vestigial thing from other tries.
Yeah. Now it's live coding, right? Now
There
we
you
did
go.
live coding on
Oof.
at least on paper. Yeah, but I really like this line because it again I think shows how in idiomatic Kotlin code you can be very expressive. You can have a range. And you can check whether a value is in that range using the in operator, which makes this read very naturally. It's literally, is my adjusted index in this range?
Yeah, I really like to do those things actually. I may not be the fastest or like the one-liner kind of person, but I really like to have this kind of little things here and there.
Yeah.
So yeah, that was basically it for this problem. But I was not happy with me printing things because I wanted to validate my example. So I swapped to, instead of printing things, the part 2 be arrays.
Okay.
I create an array with the things. I again just mesh in the drop pixel thing in there. Ignore it. But it's really basically doing the same. In this case, instead of printing things, I am creating kind of the screen, which is a 6 by 40 kind of matrix. And in each of the matrix, I am just updating the value that I have for the pixel to be drawn. And that actually allowed me, if you go follow my pointer.
I'll follow you.
Over here, I am pasting the solution for the example, and then I'm just like checking if my solution is correct or not. And yeah, I was kind of angry because I had commented my part 2 and I already had like my other examples with part 2 validation. I was like, I want a validation here too. So that's why I created the array.
Nice. And the parsing itself seems pretty straightforward.
I mean,
you do trim indent to make sure you get rid of all the leading characters. You split it by lines, and then you turn each one into a char array. Okay.
Yeah, and since I'm working with arrays, because I always, I mean, arrays are more efficient for this kind of thing. That's why I work with arrays. And just
you mean
for the sake of it,
you mean over array lists? You mean?
Over lists in general.
Okay, yeah.
And just because I was already there, I wanted to compare, so I created one with lists.
Okay.
And just for benchmarking it, and yeah, it's like half efficient as the other one, like.
Really?
Ish. Yeah, at least in my computer, it was like a 30. I did the maths. It was like a 39% difference between the arrays and the other one.
Wow. Now I have to admit that I did not expect.
Yeah, I was expecting a little bit closer gap, but at least in my computer, working with lists is less performant.
Okay.
So it was nice. It was nice to play around with it.
Ah, interesting. So that's I guess something to keep in mind if at some point there's a pathfinding problem and I need to squeeze out a cool 39% speed boost. Maybe I'll just need to move to arrays from my lists.
And you know the size of the thing you want, because that's kind of the key.
Yeah, if I do, I'll just allocate a bunch and just keep track of the size
array,
manually.
120.
Exactly. So I'll build something where I have an array. I keep track of the size, and if I ever go over the size, I allocate a new array.
It?
Exactly. Yeah. So I'm just building an array list by myself, and I'm sure that's gonna be faster than the super optimized version that's built into the standard library.
I mean,
I'm sure.
You can benchmark it and see how it goes.
Yeah. I mean, who knows at this point, right? A lot of surprises happening everywhere. Okay, this is it's really cool to kind of also just see how the two solutions overlap quite significantly in essentially what's happening, right?
Yeah, it's basically doing the same, just one printing. By the way, of course, the printing one is super slow in comparison.
And any guesses as to? I assume that's just because printing to standard out is kind of slow.
Yeah.
That
was my assumption as well.
which I think is the classic of my path-finding algorithm in Advent of Code doesn't terminate in a reasonable time. Let me remove all my debug print statements. Oh, all of a sudden it's done in like 15 seconds. Now it's reasonable. Okay.
Cheap it.
Exactly.
Yeah, basically.
GA says, amazing you take care for performance. I didn't know there is a Kotlin alternative to JMH. Very nice. Need to check it. Yeah, so the framework that Nicole and us in general are using is Kotlin X Benchmark, which in fact is not an alternative to JMH. It's actually a wrapper. So under the hood, at least on the JVM, this one actually does use JMH, the Java Micro Benchmark Harness, I think is what that's called. Yeah, but of course it also supports Kotlin multi-platform projects. So if you're benchmarking native stuff or Kotlin JS stuff, you can do it with this one as well. And it of course makes a couple of more affordances that make it easy to work with Kotlin code. So yes, if you are interested in looking at your at creating micro benchmarks for your code, then Kotlin X Benchmark is the way to go. Did you think it was it easy to get set up and get started with, or did it give you any trouble?
For benchmark, I actually set it up a couple of problems days ago. It was a bit kind of clunky. I had to like fiddle with it a little bit in order to make it work. But it was not that bad. I just had to Google a couple of things and it worked. Okay,
understood. Yeah, I think people, the best thing for people is to look into the examples directory, especially if you're using KTS. Yeah. Now, unfortunately, these samples, at least for the dependencies, they use this project notation, which is not what you're going to have in your project, because this only works inside the repository. But the important parts are all of these plugins, or at least these three, are actually necessary. You can't skimp out on the all open plugin, otherwise it's not gonna work. You can't skimp out on the all open extension configuration. Those were all the things that I kind of did in the beginning that I was like, oh, okay, that's why it doesn't work.
And also need to consider that you need to create a package for your things, and you cannot pass parameters. That actually annoy me a lot, that I cannot pass parameters to the things for the setup, for example. That's why I ended up like creating class general parameter there. Yes, at the top here. Yeah. So yeah, it was just like, but it was just an ugly patch fix thing. I didn't actually invest too much time on this. It was like, oh, this should work. Can it work? I was like, okay, I'll figure it out later.
That's perfectly okay. We don't judge any like hacky code around here. It's Advent of Code time. Everything's allowed.
Everything's hacky anyway. Great.
That's right. Okay, nice. So from there, we can of course briefly take a gander over into my code, which looks slightly different, and we can kind of compare a little bit. So we're gonna take a look here at part one. Well, we're gonna take a look at the main function first. I decided, well, these are instructions, and who knows what Eric's gonna make me do today. So first thing is I'm just gonna parse them. Create a little parsing function. I decided to go with a different flavor this time around, where it's just a top level function. Of course, I could just convert this parameter to a receiver, and then it would be my fun little extension function that I've done beforehand. Or of course, we could do like an instruction.off, as we've seen in the previous days as well. That part doesn't really matter. Yeah. I completely inverted the code from what Nicole did, so I'm checking if something starts with no-op, and if it does, then that's clearly a no-op instruction out of my sealed class hierarchy that I have up here. And if it's if it's not, then it has to be an addx instruction. So I split my string. In fact, I probably don't. I could probably just directly go for the second part. You can see that these are still remnants of me just spamming out this code very quickly. That's why this one's just called foo. Yeah, and we just create our addx object. So we just end up with a list of type safe instructions that are sealed classes.
I actually considered doing one solution with that as well. Just creating the solution center. Please continue. And if you might, can you zoom a little bit?
Oh yeah, absolutely. I absolutely can. There we
Thank you.
go. Thanks for pointing that out. Because I just for context, on my screen is like this big, so I sometimes keep forgetting
No
to zoom.
problem. It happens to everybody.
Yeah. So and then just for scoping purposes, I put these in objects, and I just created like an execute or like a main function, which all it does is well, it executes the code step by step depending on the instructions. If it's an add x, I introduced a function called signal, which essentially is a cycle of the of the CPU, which kind of it signals the that, or this is the point where I need to check the signal and do some other operations, and then after these cycles are over, that's the point where I add whatever my instruction initially wanted to add to my my x, which in this case is just a variable attached to the object. If I didn't scope them within an object, these would essentially just be file level variables. Yeah.
Nice.
What the signal does is it just increments the cycle by 1, and then this is not so nice
That's
solution.
what you mentioned.
Exactly. This is not quite as nice. I was just okay.
You can change it right away.
Now that I know, I can just be like, and obviously this one can be refactored to cycle mod 40 equals 20. That's something I just came up with on the fly there, all on my own.
Live coding.
And I mean, this is much nicer. Yeah, and then I have a just a list of a mutable list of signals that I keep track of, which these I could actually also move into my object just so that they're properly scoped. These are just where I keep track of them, because I was like, maybe we're just gonna take these signal strengths and we're gonna find out something else about them in part 2. Let me keep track of all of them. You could have, of course, also just summed them up. So don't be fooled by the fact that there's a plus equals. That just adds it to the signals list. And then the last thing that I do is I sum those all up. And that's pretty much the first part. Nothing crazy here. For me, this function of like signaling helped me just kind of think about the cycles. I was like, okay, we're gonna do 2 cycles and then an operation, and with the other one we're just gonna do 1 cycle. So I guess I didn't want to overload the term cycle too much in my brain, which is why not everything's called cycle. This sounds like signal, but yeah, that's kind of that part. And then for part 2, I pretty much inlined a bunch of the code that we've already seen beforehand. So this time you can see that. So first of all, you can see that there's a bunch of comments here. Now, if you're seeing comments in my Advent of Code like solution, that usually means that I probably did something wrong in the beginning. So I spelled out like things. Yeah, sorry.
Oh no, sorry. Continue.
Yeah, usually me spelling things out in the code means I try to make sure I map the problem statement directly to my code. Because before, and I was just kind of like, okay, well, you got like a bunch of, some things happen, then a draw happens somewhere, and then your execution execution continues. So if you're seeing comments, that's usually the part where I probably twisted something around.
Nice. It's fine. I mean, whatever helps you to translate whatever you're thinking there, it's fine. I have to say that sometimes draw if I'm stuck, so probably similar.
Yeah. And this time I actually called the function CRT, because this is like whenever the CRT gets to do something. Like kind of the CRT clock cycle, or like the place where the CRT is currently pointing. I first define the sprite, which is something that you've done inline in your code. I do a check to see if we are the last character, or the last row in a line, which means we need to introduce a line break. My sleepy self in the morning first put this block of instructions down here, which yeah, that does not give you the result that you want. That kind of twists everything by 1 or 2 characters. And I was like, am I going insane? Like, I've printed 2D structures so many times. What's going on? Yeah.
I was this close to do the same. I wrote it down. I was like, wait a second. When is this going to happen? And then I just move it up.
Yep. Smart.
Yeah.
Smart.
Same thing.
Yeah, and then we just check if the horizontal positioning, so CRT mod 40 is within that range. Then we print the hashtag. Otherwise, we print the dot, and then we increment our the position of our CRT. So at this point, I was kind of thinking about things in terms of where is the CRT currently, and not where is my current cycle, because that part kind of got me confusing. It's like, what's before, during, and after a cycle?
Yes.
That was harder for me to reason about than saying, like, where is my CRT currently pointing? And that's what I'm looking at.
Yeah, my initial thought was also, like, as I said, thinking into pointers and then, like, try to match them up. And then that's when I did the jump, like, hey, the cycle is always going to be a 1 plus, like, the CRT, whatever. So,
yeah definitely. Let's see here. We have Maya saying, I printed a blank screen of dots and then a screen of indexes till I got it right. The things that sleepy self will do. Yeah, I think that's easily relatable.
Yeah.
This is Alexander says, wow, if we just store all signals, not every 40th, starting with the 20th, then we can move all the reused code for both parts into one function. And he says, then each part will just be like, compute the signals, print the sum on a subrange, or compute signals, print signals, map indexed. That's an interesting way of thinking about it as well. I'll be very honest with you, when I'm up at 5:55 a.m., I'm not in the state to plan that far ahead.
No. Me neither. Yeah. But I agree. This actually, as you can see, my solutions are pretty similar, both of them. So probably we can just mesh them together, as Alexander is saying.
Yeah.
But yeah, I agree. Like at 6 a.m., my brain was also not there, and with the sickness as well, I was like, "This works. That's it. Now let's play around."
Yeah. I guess so. I've asked guests on the previous days about what they are kind of seeing in store for us in the next couple of days, and virtual machines came up a couple of times on a couple of days. I'm not sure if this one already counts as like checking this off, because it's like it's 2 types of instructions, but it's the classic thing of parsing an instruction and then looping over it and changing some kind of state or an accumulator. So certainly the prediction wasn't wrong, but I feel like it might not be the last time we see one of those this year.
Yeah, no, probably not. It's just day 10. We're not even half of the day, so probably it's going to be there.
Do you have any predictions? What might be next? Anything out there?
Predictions? Exotic? Anything exotic? I was expecting something like pathfinding, something like that. But I am not sure. As I said, this is my first full advent of Coach. I don't know, kind of the things of problems that come up, but I would really like some pathfinding something in there.
I have to admit, I'm still traumatized about one of the previous years where it was reasoning about, I think, overlaps of 3D cubes. That one was, I did not like that one. I think that was one of the ones where I looked at it for like 6 hours and I'm like, is this really? I feel like even if I got the star by now, I'm not sure
if you would complete it. Yeah, I understand those kind of problems. We all have our favorite kind of things. I imagine. Whenever we find them, it's just playing around. If not, you drag over.
Yeah.
Yeah, no, that's actually what I do when I find those kind of things. I just try to write everything that I have, like how I see it, just bleh, and try to see what happens. Start fooling around.
Yeah, a nice little bit of tinkering.
Yeah.
So let's celebrate our little thing we did here, because Olaf, who's been submitting a bunch of visualizations for the couple of previous days, has submitted one for today as well, which simulates quite nicely, first of all, the static flickering of a CRT, and the way that the cathode ray kind of moves across the screen, the way that the sprite moves across just horizontally, and how that means that the whole screen slowly draws out the actual solution and the final text that you then get to interpret using our human eyes. And of course, I have to say, I very much like the visualization with the fact that it's repeating. It really does feel like a CRT.
That's really cool.
So yeah, very exciting stuff from Olaf as usual.
Yes, thank you for sharing, Olaf. This is great.
So and this is also a great time to advertise the fact that if you like visualizations like this and you would like to get to know the person behind these, guess who we have as a guest for tomorrow? That's right. It's gonna be Olaf. Olaf is gonna come on. We're definitely gonna talk about his visualizations and the framework that he's been kind of building up to do these kind of graphics. We're also gonna talk programming challenges and a bunch of other things. And I think that's going to be a great time. At the usual time tomorrow again, so at 6 p.m. Central European time, or I guess that's 5 UTC. You can do the conversion. Yeah.
Pesky time zones.
Exactly. Well, we have our hour almost filled up again. So I think it is time to wrap up for us, because I need to dress up very sharply to make sure I make a real impression on the during the Christmas party. I'm still contemplating taking the reading hat.
I was just going to ask that. Nice.
Yeah, I think it would look fun and quirky. I'm not sure if it gives the professional aura, but we'll see. We'll figure that out, and hopefully there's gonna be some nice food and glühwein for me to enjoy. You got any nice plans for the weekend? Anything fun, or is it just gonna be? Are you actually waking up at like early in the morning to do Advent of Code, or are you taking it a little bit more chill?
I am probably going to take it easy this weekend. Sadly, I even got my sweater for glühwein as well. With the sickness, I'm not going to be able to go anywhere. But next weekend, I'll get there with a vengeance. So
fair enough.
That's where the Christmas markets are going to be.
Nice, wonderful. Well, that's all in the spirit of the holidays.
Of course.
Yeah.
Not to get drunk.
That's right. Well, I think these are great words to end it on. So I want to say thank you so much, Nicole, again, for coming on today and bringing so many variations that you've even benchmarked beforehand. I like them a lot.
Thank you. It was fun. Thank you for sharing that library, actually. I didn't know about it until you shared in the stream. So thank you for that.
Look at that. Wonderful. Everyone's learning something new. I learned something new about the modulo operator, or the remainder operator, as people usually point out in the chat. It's not modulo. And yeah, and you've learned something about benchmarking. Isn't that great?
It's great.
It's a
Thank
sharing
you
community.
for making this thing. It's been fun. Thank you for having me. Thank you all for joining.
Yeah, I can only second that. Thank you all for tuning in today at a bit of an earlier hour. So we really appreciate you coming on. And we, of course, hope to see you again tomorrow, where we're going to be talking with Olaf. Make sure not to miss it. I'm sure it's going to be absolutely wonderful. Enjoy the rest of your Saturday, and we'll see each other when the new Advent of Code puzzle is 12 hours old. All right. Take care, everyone. Bye-bye.
Bye-bye.